Okay, Bismillah ar-Rahman ar-Rahim. Inshallah, today we're going to start chapter 4. Again, the book tries to combine the security services that have to do with each other together in one chapter. So we'll see now that user authentication and key distribution, they are actually conducted usually together. So usually, as part of user authentication, when you type your credentials, as part of this, you exchange the keys. So key distribution is actually done together with user authentication. When we say here user authentication, this is different, of course, from message authentication. Message authentication has to do with to ensure data integrity and non-repudiation. Okay, user authentication, we'll talk about it today. It's the first line of defense that we normally should do, using credentials. So remote user authentication principles in most computer security contexts, user authentication is the fundamental building block. It's the first line of defense. Like when you type your user ID and password, this is usually the first line of defense, that these credentials, no one knows it but you. Okay, so this is the first line of defense that we use. User authentication is the basis for most types of access control and for user accountability. So we use this user authentication to make sure that the person who's trying to access the system is identified, and we know that person, and we use the credentials for access control. So user with a specific user ID and password, they have, like, for example, student access. Another user ID and password, they have instructor access. Another user ID and password has admin access, and so on. So access control is attached or is done using the user authentication. So there are two standards that talk about user authentication. The first one of them is an IETF standard, which is standard RFC 4949, which is done by which organization? IETF. Defines user authentication as the process for verifying an identity claimed by or for a system entity. A person, okay, or a device, okay, as we will see, could be a person or a device, is claiming a certain identity. Okay, so the user authentication is the process of making sure that this identity is really verified. Okay, so it has two steps: the identification step and the verification step. Identification step is part of the registration. So first, when you get admitted to the university, you have to provide all your identity documents, right? So you have to provide all your IDs. Once you are identified to the university will give you credentials to access the system. Okay? So the identification step, presenting an identifier to the security system. So you present all the proofs that indeed this is your identity. So for example, if you want to do user authentication or to perform user authentication مثلا for a new account in the bank, then you have to provide all your IDs to the bank. Once you do this, the bank will tell you, okay, so now you have access to the online banking. Okay? So the first step is how you register and prove or provide all the information about your identity. The second step is the verification step, where we can use your credentials to verify your identity. Okay? So when you type your user ID and password, we know that this user ID and password correspond to this identifiable person in the system. Therefore, this user has مثلا certain privilege or certain access level to the system. okay? Presenting or generating the authentication information that corroborates the binding between the identity and the identifier. الidentifier ده اللي هو could be done using user ID and password, could be done using token, as we will see, or tickets, or it can be done in different ways, okay? But this identifier is bound to a specific entity or a specific identity of the person or the device, okay? So this is laid out in this RFC or in this standard. ماشي؟ Nest بقى, they provide another standard which is SP863. We don't have to memorize, of course, the name or the number of these standards, but they identified the same term, electronic authentication guidelines, and they defined authentication as the process of establishing confidence, okay, in user identities. So during the registration step, okay, we establish certain level of confidence. Like, for example, if you are opening a new account in the bank, the level of confidence that we should have about your identity should be 100%. There's no tolerance. But you are performing the same registration, مثلا, to have a new email on Google ولا مثلا Microsoft. Okay? Then you have to type your name and so on, and your suggested password and so on. And then we create an account for you. So the level of confidence about your identity is very low. And in fact, some of us, we use fake names, right? And we still get by. Why? Because the type of service that we have is not that critical. But if we talk about مثلا a new student admitted to the university, or someone is trying to open a bank account or something like that, the level of confidence has to be extremely high. Okay, 100%. ماشي? So this is the process of user authentication. It's divided into two steps, as we said. The identification step and the verification step. Identification is about how you provide all the proofs for your identity, and then based on that, we give you an identifier. This identifier is in a form of user ID and password or token or something like this, and then later on you can use this for verification to the system. Okay? So system can use the authenticated identity to determine if the authenticated individual is authorized to perform a particular function. Okay? So once you are verified, now and only now you can access certain levels in the or certain parts of the system. So in many cases, the authentication and transaction or other authorized function take place across an open network such as the internet. This is very important. But the problem in the verification step, okay, is that when we type user ID and password, actually, as we said, this is the first line of defense, right? So until you actually provide your credentials, there is no keys established yet. Okay? No keys are established yet. Therefore, in many cases, not in all cases, as we will see later, in many cases, this authentication step, or in particular, the verification step, by typing your user ID and password, this happens through an open channel. It's not secure yet, right? It's not secure yet. And in fact, it's one of the most critical. Why? Because if an eavesdropper can listen to your user ID and password, they can get all the keys afterwards. Everything else that we do is useless, right? Because then they can access the system using your user ID and password, and they can get all the keys, and they can do everything they want. ماشي? So this is the most critical part, and it's the first line of defense. And that's why, by the way, 80% of the hacking happens because an attacker gets your credentials. Because if they get your credentials, everything else is خلاص is broken easily. So the user ID, the authorization step or the authentication step, it takes place across an open network such as the internet. Okay? So does that mean that our password, when we type our password, it's exposed?
In many cases. No,
It shouldn't, صح? It doesn't make sense, صح? So, but we don't have keys yet to encrypt our user ID and password, صح? Because we're still trying to verify. Actually, once we are authenticated to the system, then the keys get established, right? So that's a puzzle now. So we want to authenticate ourselves to the system, but this happens across an open network, okay? Which means that we don't have keys yet. So how can we authorize ourselves without exposing our password? ماشي? So there are some solutions for this which we will discuss as part of this chapter. ماشي كده؟ So equally بقى, authentication and subsequent authorization can take place locally, such as across a local area network. طبعا the level of security required in that case is much lower, because if we do this across a local machine, يعني if you're trying to authenticate yourself to a machine and this machine has a local database which stores all the user ID and password, ماشي? Then the level of security that we require in that case is much lower compared to the fact that when you authenticate yourself in a distributed system. ماشي؟ يعني here this person is accessing a local machine, ماشي? Is authenticating himself using user ID and password. If he's authenticating himself in the local machine, then there is a local cache or a local database on this machine that stores or it's used to match his credentials. Okay? So if that's the case, then the level of security is low. We can, in fact, exchange the password in simple text because we are not sending this password across a distributed system. If we send this credentials, the user ID and password, across the internet or across an open channel, then the eavesdropper might in fact listen to this and might capture the user ID and password. So as you can imagine, the user authentication done locally or in a private network معناها local area network which is private. Everything within this network is already secure, and there is a big firewall and stuff like that. So this area is private and is protected. So the level of security required for user authentication in that case is different from when I want to authenticate myself in a distributed system, which is typically what we do for here at the university. At the university, we have a distributed system, and we perform all the user authentication, okay, for that distributed system. But if you have, like for example, a server at home, and you have a software, and you're trying to authenticate yourself, maybe in that case the level of security is low because your home network is already protected. It's a private network. So
if you send a bunch of garbage down the pipe, the attacker will know the difference between the important stuff and the garbage.
But what we're saying, we don't have keys yet in order to encrypt the user ID. In fact, the key distribution is done as a byproduct to the authentication step. Only after your identity is verified to the system will exchange some key, okay, so that you can use that key to encrypt the data before you send it to the system, okay? But before giving you that key, we have to authenticate you as a user. ماشي كده؟ So that's why we said that the user authentication, and user authentication, as we said, user authentication is 2 steps: identification step and verification step. ماشي? As part of the identification step, it's done offline. You register, you put all your information, or you give your ID to the bank, or you give all the transcripts to the university, and so on. Once we make sure that your identity is really verified, we give you some kind of identifier. This identifier could be user credentials, could be a token, could be a ticket, could be anything. Okay? Once you get this identifier, you can use it to access the system. Once you access the system and we can verify that this is indeed you, then and only then we have to exchange the key. Okay? So we cannot use encryption until, we cannot perform any kind of encryption until we make sure of your credentials or your identification. Okay? That's why, as I said before, 80% of the hacking is done focusing on user ID and password. Once they get your user ID and password, everything else is doable. خلاص. It's the first line of defense. Okay? And that's why in this chapter we discuss both together. The user authentication and key distribution. Both. Because in distributed systems, they are done together. Okay? And we'll see now how we could do this. Okay? So the level of security required when we exchange this identifier or this credentials across the internet is different from using a local machine or a private network or a local area network. The level of security is different. So this is the authentication architecture model, which is laid out as part of this NIST standard. Okay? This NIST standard lays out this architecture to explain how the user authentication process is done. ماشي? And it's done, they define 2 phases corresponding to the 2 steps that we have talked about. There is the identification step. This is the identification step. This step is usually done offline. Okay? Like imagine yourself opening a new account مثلا on Google Gmail مثلا. Okay? Then you have to put all your information. Okay? Then we establish some confidence about your identity. As we said, this confidence level varies from system to a system. Gmail, confidence is low. You may actually create 2 accounts with the same name, right? There's no problem. You may actually fake your name. So the level of confidence about your identity is almost 0. Okay? If you try to do the same thing by opening an account in the bank, خلاص, there's no chance. You have to provide all your IDs, you have to provide everything that proves your identity, right? Then and only passport or IDs شغلانة. Then and only then we establish a very, very high level of confidence about your identity. Then we can give you some user ID and password, for example, to do online banking or to access your account through the ATM and so on and so forth. Okay? So we have to give you an identifier that attaches this identifier to your identity information. ماشي? So that's what happens. So this registration step is usually done offline. ماشي? And it starts by the subscriber or the claimant, which is us, يعني, a user, or sometimes it's a device. So let's imagine that it's a user. So this user first tries to access a registration authority. This registration authority could be a server, or it could be a bank client. ماشي? Or it could be the registrar office in the university. ماشي كده? Then we provide the identity proofing. ماشي? Once we provide the identity proofing, this is step number 1. Then we establish some confidence. This is step number 2. We establish certain level of confidence about this user identity. This level of confidence could be low or could be high depending on what system we're talking about. ماشي كده؟ So once we do this step, this registration authority will send a confirmation, this is step number 3, to a credential service provider. This credential service provider is the entity that gives you the identifier. ماشي? It gives you that identifier. So once you have this identifier, and we'll see that this identifier could be exchanged physically or could be exchanged through a secure channel. We'll talk about the different types or different ways of getting that identifier. And then once you have it, then you use that identifier to verify your identity to the system. And then once we verify your identity, now you have done the user authentication. Sorry, the verification is done here. Sorry, the verification is here. So this is step number 4. So this verifier, by the way, in many cases, it is the same credential provider. Yeah, that's why there is a line here. So in many cases, these entities are merged together. ماشي? So the verification step, this verification step is done on demand. يعني this is done offline once and for all. صح؟ اللي هي registration step. This verification is on demand. Whenever you try to access the system, then you provide your identifier to the verifier, and then the verifier will say, okay, so your identity is confirmed. Okay? As part of this, it gives you access to a particular server. ماشي? So you get to مثلا MyQU or the university domain. Now you get access to email, you get access to your grades, you get access to whatever. ماشي? So the verifier, once the verifier verifies your identity through the credentials, it gives you access to this server. And usually this access, by the way, it's not forever. This access is timed. Okay, so it gives you limited access. So this access is timed in terms of lifetime, and it's limited in terms of the type of access you have to this server. ماشي? So you have, for example, a student access to Blackboard, but I have a faculty access to Blackboard. Somebody else has admin access to Blackboard, right? So access control is also part of user authentication. So once your identity is verified, your access is limited by time, and it's limited by the type of access or the privilege that you have. ماشي? So we'll see about how this is done, this lifetime, how this is done in distributed systems. We'll talk about a specific يعني security service or standard that's used to facilitate this user authentication and access to distributed servers, ماشي? Which is done by MIT. So we'll talk about it probably next time, not today. So this, تفضل.
What's the difference between these two squares?
Yeah, as I said, this square focuses on the registration step, which is usually done offline once and for all. This step talks about the verification step, which is done on demand whenever you try to access the system.
So is it online?
Yes, this one is online, on demand. Whenever you try to access the system, okay, we have to send your identifier to the verifier. The verifier will tell you, okay, you are verified, which means that you have a timed access to a particular server or a group of servers. ماشي? So this is the process and how it's done in distributed systems in general. طيب. So what are the means of authentication? In other words, we talked about a certain identifier which identifies your identity. So sometimes this identifier is represented by something the individual knows, like user ID and password, or PIN number, or something like this. So you should know and memorize these identifiers or credentials in order to authenticate yourself or to verify your identity to the system. ماشي? Or something the individual possesses physically يعني. You don't have to memorize anything, but you have to possess this device. So it's either a cryptographic key or electronic key cards. This is something that you physically have. Okay? So in the assignment, for example, you will have to possess this cryptographic key and use it to encrypt all messages in a messaging system. Okay? Electronic key cards, probably none of you have seen this, but I used to have it when I was working in Canada. So we had like a physical device. Okay? They call it a physical token or electronic key card. They have a different name for it. So all this device does is just it gives you a specific random number, okay, which you use to authenticate yourself to the system. Okay? So you don't have to memorize. It's just that you have to see this number, and then you type it, and then you get access to the system. So as long as you have this physical device, so which means anyone else who has this physical device, they can access the system. Okay? So sometimes, by the way, you can use one or more of these. That's why now we have a two-factor authentication. So your user ID and password is not enough. So we also send you something on the device, on your mobile device, and then you have to enter that code. Okay? So these identifiers or these credentials, they can be used individually or combined. ماشي? So this type of identifiers or credentials, they are called a token. ماشي? So you have a token that it's like a random number. So the key, the cryptographic key is a random number. ماشي? Electronic key card is a random number. Any kind of يعني number combination that you don't have to memorize, but you just get it somewhere, somehow, okay, using a physical device. ماشي? And then you have to present this token to the system every time you want to verify your identity to the system. ماشي? Or something the individual is, okay, like your signature of the eye, fingerprint, ماشي? Or iris or something like this, ماشي? Or something the individual does, like your voice, ماشي? So any of these, as we said, or handwriting طبعا, signature.
To confirm two-factor authentication is part of visual possessions, right?
You can combine any of these.
Right.
You can combine two of any of these. ماشي? So examples of something that the individual does is to include recognition by voice pattern or face, but face is biometric. Handwriting, something that you do. ماشي? So the two parties must share the same key, and so this is regarding user authentication. ماشي? Now we talk about a different subject, which is key distribution. ماشي? Later in this chapter, we will combine both and see how both can be done together. ماشي? يبقى bear with me. يبقى the first part we talked about user authentication. ماشي? We're done with this. And we said that user authentication is different from message authentication. The purpose is different. Huh? Here, for key distribution, we know that the requirement for symmetric key cryptography, for example, is that both they have to have the same key. ماشي? How they have been given this key, until now it's a puzzle for us. We don't know how we can distribute these keys and make sure that two parties communicating together, they have the same key. We don't know how to do it until now. ماشي? So, but we know that frequent key changes are usually desirable to limit the amount of data compromised if the attacker learns the key. Why? Because if I give you a certain key, and imagine that this key is secure, okay? You communicate for a long time. The more you use this for communication, the more time the attacker will have in order to perform cryptanalysis, right? They can perform cryptanalysis or brute force or whatever to try to guess what the key was, right? So this key has to have a certain lifetime. It cannot be used forever. It cannot. And the more you use it for communication and sending data, the more you give data to the attacker to try to guess what that key is. ماشي? So for key distribution, we have two very important aspects. We have the key distribution technique, right? So we need a technique now for key distribution. We need a certain technique for key distribution. We don't know how to do it until now. But we know that we require a technique to do this, because if we, for example, exchange the key over an open channel, anyone listens to the key, they will be able to break the communication. صح? So we need a technique for this. The second thing is the key management technique. Key management is slightly different from the key distribution technique. Key management here talks about the fact that the system has a pool of keys. Okay? How do they generate these keys? They generate these keys based on generating random sequence. Remember we talked about pseudo-random generators, right? So they use pseudo-random generators to generate these keys. And the requirement for the random generator are two, which are unpredictability and true randomness, yes. ماشي? So imagine that we generate a big long sequence of random sequence, and we can break it down into pieces, and then we can use the keys. So key management here talks about how bad to maintain these keys. For example, if I give you a key that you use for a certain period of time, and then I give you another key, the other key should have no correlation with the previous key, right? So this is what's done here. So key management here, given large number of keys, how do we preserve their safety? ماشي? Because if I give you a key that has a correlation of the previous key, then the cryptanalysis can be done. Once the cryptanalysis is done on one, خلاص, they can guess the other keys easily. صح? We don't want to run into this. So key management here talks about the correlation between the keys and how and when we trigger the process of changing or replacing a key. ماشي? Once we trigger the fact that this key should be sent to two parties, now we kick off the distribution technique to distribute that key to these two parties, to use it for secure communication. فهمنا الفرق؟ ماشي؟ يبقى key distribution technique is like a function, you give it a key, ماشي? And you give it party A, party B. ماشي? This is the key distribution technique. So this technique should somehow give this key or deliver this key to these two communicating parties so that we don't have any security breach. ماشي? Which we don't know how to do until now, but we will. Okay? Key management talks about the fact that key management here talks about the fact that we have key 1, key 2, and key 3, and so on. Okay? So when do we call that function with a specific key between A and B? Okay? So which key should I give to these communicating parties so that I can kick the key distribution technique with this key and these two communicating parties so that they can exchange that key and start communicating securely. ماشي? So these two techniques they work hand in hand. By the way, one of the things that is not addressed enough in the research community is this key management. Not many people طيب, what are the ways that we use for key distribution? What are the possible ways we use for key distribution? These two methods are easy. We say, okay, we distribute these keys physically. ماشي? Physically. So if two parties, they want to communicate, then A can be selected by A and physically deliver it to B. The key. So A and B are trying to communicate. So A will say, okay, so I can generate a random number. ماشي؟ وديه كده الاوفيس بوي يقوم واخده كده ويروح يديه physically. Now this is the only way we can secure it. Hopefully يعني. Maybe the office boy will give it to someone. ماشي؟ بس يعني ايه because if we send it over the network in any way, ماشي؟ خلاص we cannot guarantee its security. ماشي؟ طيب, what is the other way? A third part, but طب يعني someone might ask for the first method, why do I have to trust A? ماشي؟ نحن بنقول A will generate the key and will give it to B. طب why do I have to trust A? ماشي؟ when I communicate with محمد ولا ممدوح ولا كده, this is a person يعني. ماشي? That's why they say that we have a third party. A third party is like بقى a bank ولا university. هتقول لي why do I have to trust the university? I mean, you don't have any choice. خلاص يعني when it comes to something like that, يعني you trust the hospital, you trust the university, you trust the bank, but you cannot trust someone else. You cannot trust a person, صح? No, you can trust an entity. So a third party can generate that key and then give it to A and give it to B. How? Physically برضه. يعني محمد يروح كده للبنك ياخد الكي, ممدوح يروح للبنك ياخد الكي. Now they can communicate to each other. ماشي? That's the second method. These two بقى talk about distributing these keys بس electronically through an open network. So if A have previously and recently used a key, so imagine that for the first time I give you the key, ماشي? Physically. So now we can communicate, but we know that this key has a certain lifetime, and after some time this key has to be replaced. Okay? طيب بس احنا بقى يعني الاوفيس بوي بقى هيتعب معانا, مش not every time we have to call the office boy. لا احنا we should be smart. First time I give it to you physically, but before the lifetime of this key I can use it to encrypt another key and give it to you. ماشي? This بقى can be done on any communication channel, صح? Electronic, any channel, any network channel, صح? We have a key, we established that key previously, ماشي? So we can use that key to encrypt the next key. Similar to the fact that we encrypt. هتقول لي طب why bother? طب ما use the first key. ما احنا قلنا بقى before the lifetime of this key, before I give enough chance for any attacker to try to use cryptanalysis to guess what that key is, before that, okay, it's better to use that key to encrypt another key, and then we use it for future communication. Then all the cryptanalysis that this attacker has done is useless. صح? He has to start from scratch. Okay? So he had to spend like 3-4 days. Before the 3-4 days finish, I will use that key to again encrypt another key and so on. Okay? But the problem is this first one, until now it has to be done physically. Okay? This is the only way you can secure it. ماشي كده؟ The fourth one, which is the most common one, especially in distributed systems. Again, why do I have to trust A, which I'm trying to communicate with? I can easily trust an entity or a third party, okay, which I have to trust anyway, like a bank or a big مثلا اللي هو مثلا university server اللي هو the centralized server in the university. I can trust that. ماشي? So if A and B each have an encrypted connection to a third party C, So now this is A and this is B, okay, and this is C. As we said, through method 2, C has generated this key and physically بقى مثلا ولا أي حاجة, and then it uses that key to communicate with A and with B. Okay? So here there is key A, C, and there is key C, B. So I can use this to send, to encrypt يعني a key A, B, and then to send هنا key A, B. Then and only then A and B they can talk together. واضحة دي؟ ماشي كده؟ This is the most common method in distributed systems. ماشي؟
Would they renew?
Yes, of course. We can بقى renew it later. يعني C بقى can run the key management. So key management is done at C بقى, in the C node. So after some time, if A and B still want to communicate with each other, C will say, okay, so kick the key distribution. The key distribution will take KCB and KAC and then send another key AB ماشي, to both parties to continue communication.
But would that mean for a moment both would be unencrypted?
Sorry?
Would that mean for a moment that both wouldn't be encrypted?
For-
If you remove the key from both of them and then replace the key, while you're replacing it, would
لا انت you send another key here and another key here, and then you ask A and B to replace the existing key with that new key, and then they can communicate. ماشي?
Is it like
It has to be done through a protocol, which we will discuss. احنا until now we're saying the concepts. We're talking about the concepts. Later on, we'll talk about a specific standard and see about how it does this. How they actually do this. ماشي?
is it like an authority?
Yes, of course. CBA is an authority, is a trusted authority. ماشي? Same thing, we distribute certificates. Certificates, they use certificate authority to distribute this. So this is the concept, this is the abstract concept. ماشي? So I can use this authority or this third party to communicate حتى not necessarily a shared key. I can communicate even the public key. ماشي? But somehow the public key has to be done locally, and we'll talk about this, because no one should know the private key. And the public key and the private key should be generated locally, and then I exchange the public key. ماشي? So we'll talk about here. This key is what we call the permanent key. ماشي? I use it to communicate with C. Once I communicate with C, C will send me back this key, which is a temporary key. ماشي? So later on, A wants to communicate with D. So A will send a request to KDC. I want to communicate with D. Okay, so KDC will say, okay, so I will generate a temporary key, I will give it back to you, and I will give it back to D. So A and D now can communicate, and so on. ماشي? We'll talk about it now. So key distribution, two types of keys, not key methods بقى. There are two types of keys. There is a session key, and this is a permanent key. Session key is what we talked about, that it has to be temporary. ماشي? It has to be temporary, and it's used. So for example, if I want to check my email, okay, I should be given a session key that I will be used to just check my emails. Once I finish checking my emails, this key is gone. It has no significance. خلاص. Okay? And there is permanent key. Sometimes they call it master key. This master key is used for distributing the session key. ماشي? We'll see about this master key. How do we exchange the master key in the first place؟ يعني احنا الاول ماشي يعني البيضه الاول ولا الفرخه زي ما بيقولوا يعني. فاحنا we need the permanent key to distribute the session keys. But how did we get the permanent key in the first place؟ ماشي؟ This permanent key, in many cases, could be a public key, or it could be exchanged through certificates, as we will see, because certificates usually are easier for key distribution. ماشي؟ طيب, key distribution center بقى grants two systems to establish a connection. This is what we refer to as third party, and provides a one-time session key, and it works as follows. When host A wishes to set up a connection with host B, it transmits. This is which option? This is option 4 that we talked about in the previous slide. Now, C, or the third party, is what we call key distribution center. ماشي? So if A wishes to communicate with B, so it transmits a connection request packet to KDC, to the key distribution center, ماشي? Through encrypted link. Somehow, this link with C is encrypted, as we said. ماشي? So, link using a master permanent key. So I always have a permanent key with C, or with the KDC, اللي هو key distribution center. This master key has only one function: to just communicate to the third party to get the session key. ماشي? So I send a request to C and tell it, I want to communicate with B. ماشي? I want to communicate with B. So C will say, okay, so I will give you a key, and this key is temporary, that you can use to communicate to B for a certain period of time. This is the session key. واضح كده؟ So if KDC approves the request, we'll see بقى how, يعني on what basis بقى KDC approves that request. It generates a unique one-time session key, and then it encrypts the session key using the master key, and then send it back to A. ماشي? Similarly, it encrypts the session key and then sends it to B. So now A and B can talk. A and B can now set up a logical connection and messages securely. طيب. So what is the complexity of the number of keys? The complexity in terms of the number of keys required. If I have n different nodes, okay? N different nodes, they want to communicate with each other, okay? What is the maximum number of session keys I need to have in a distributed systems with number of nodes equal to capital N? ماشي? So the worst case scenario is that every node will have to communicate with all the other nodes, okay? Which means that all the nodes are engaged in communicating with each other. So, in other words, I have a session like this, session like this, session like this. I have like a mesh network of communication. يعني. ماشي كده? So how many keys do I need in the case of symmetric keys and in the case of public keys? So for symmetric keys, it's basically n combination 2. So each two nodes, they need to communicate together. صح? So in other words, each node wants to communicate to each node in the n nodes. It wants to communicate to n minus 1 nodes. صح? And I need to multiply that by n. However, if I do this, I have to make sure that it's not redundant. So A communicating to B or B communicating to A, they in both cases they use the same key. So I have to divide by 2. So it's n times n minus 1 over 2. Or in other words, n combined 2. ماشي? So this is for the session key. ماشي? So the symmetric key has to be generated for any two parties who are trying to communicate. So in worst case, I need this number of keys. For the case of public encryption, it's not precision. It's not precision. Okay? This is the main difference. For that reason, there is a big misconception that some people, they think that the key distribution for the case of public encryption is the same like symmetric. No, it's easy. It's less. But also there is another misconception that the key distribution for the case of public cryptography is 0. لا, it's not 0. Okay? So for any network of n nodes, I need basically 2n. That's it. Why? Because each node will have a private key and a public key, regardless of which other node it needs to communicate with. This public key will have to be given to everyone, and the private key locally. صح? So in that case, it's not per session. ماشي? This is the fundamental difference between the two. So it's not per session. I have private key, I hold it, and I have a public key which I give to all, regardless of who wants to communicate with who. ماشي? However, we have to يعني in practical systems, by the way, the symmetric encryption is used for confidentiality more commonly compared to public encryption. And public encryption is used to facilitate the key distribution. ماشي? So public cryptography is used to facilitate the key distribution. So somehow I generate the private key locally, and I give the public key to everyone. ماشي? So usually they use the public key to encrypt the session key and send it to me. Okay? The good thing about public cryptography is that the private key and the public key initially they get generated locally, صح? Based على ال P and Q, فاكرين? Based على ال P and Q, they are local. ماشي? And then once I generate the public key and private key, the public key I can give to everyone. It's public. And a private key I hold it in. Okay? So this way, so it's like equivalent to giving the other parties this key physically. Whether physically, I don't care. Everybody can have the public key. Okay? So now this can be used efficiently to exchange the session key. ماشي? So we can use the public key to encrypt a session key and send it to the other party, and then the other party will be able to decrypt that key, and then from now on we use it for communication. طيب, the question is, why not use the private key and the public key for encryption من الأول? It is slower. So this is this fact. So the symmetric encryption has less complexity in terms of the time. Okay? So if you have the same key size, and use symmetric encryption اللي هو based على transposition و permutation وكده, the same key size you use it for public cryptography اللي هو based على exponent وكده, لا, calculating this exponent, by the way, is highly complex. It's very highly complex. So for the same key size, public encryption has higher complexity. ماشي? So that's why they use it initially just once. In the beginning of the communication, they use it to exchange the symmetric key. Once we exchange the symmetric key, خلاص, it goes out, and then اللي هو يعني we use طبعا we exchange the public key through certificates, which we will talk about it. ماشي? Once we exchange this, خلاص, we encrypt once the session key, and then we use the session key from now on for communication. ماشي? So I do it in one step rather than for every single message I have to use encryption using the public key, which is highly complex. واضح كده? Any questions? For this particular reason, they use the public key to waive or to avoid this physical delivery, because it's generated physically inside locally. And then once we generate it and exchange the session key, خلاص, we don't need the public key. ماشي? So starting from here, we will talk about the standard which is based on a technique or a complete implementation that was done initially in MIT. And later on, it has become like a de facto standard that everybody uses for user authentication and key distribution as part of a distributed system. So until now, we talked about the concept of user authentication, which is done in 2 steps, and we talked about key distribution. So now we will combine both in this in this tank. ماشي كده؟ Any questions? We'll talk about it next time إن شاء الله. تخافش. مش عن حسابي.